let's talk here about which functions do and do not have horizontal asymptote lines. This is not on a handout that you have. This is just some examples that I just wrote up. So you might want to pause the video perhaps and copy these examples down into your notes. But anyway, what we know is that to find horizontal asymptote lines, we take our function and we take the limit as x approaches infinity. Okay, we should consider the limit as x approaches positive and negative infinity, but as we mentioned, it's like 99.9% the same result. So if I look at this first function, and I hope you recognize this as a version of our standard parabola, which is y equals x squared. And sometimes students will even think, you know, if I'm asking about horizontal asymptote lines and vertical asymptote lines, sometimes students will even go like this and say, oh yeah, vertical asymptote lines right here, right? Because sometimes when we draw our function, it can be misleading. There are no vertical asymptote lines in the function y equals x squared. All right, that is because the domain is all real numbers. There's nothing that I can't input into this function. Therefore, I can't have a vertical asymptote line, right? Vertical asymptote lines occur when there's values of x for which I cannot input them into my function. Because what really happens to the function y equals x squared is that as x gets larger and larger, right, this function really is going like this and right up off my page, right? And it's going like this, okay? So as x approaches infinity, for the function x squared, I mean, think of it. I get a huge number and I'm squaring it, right? This limit would also be infinity. Okay, so this tells me that this function y equals x squared can have no horizontal asymptote line either, because when I take this limit, I have to actually get a real number value in order to have a limit as x approaches infinity. So if you look at the function there in A, I hope you recognize how that is just a shift of our standard parabola. All right, so the plus 3, right? If we were in class, I'd be asking the class, which way does that shift my function? And when I have it in parentheses with the x, a little bit counterintuitive. People want to move it in the positive direction, but it actually shifts over 3 to the left. And then the minus 5 brings the whole parabola down 5. Okay, and this function would look like this. The vertex would be -3, -5, and there would be no horizontal asymptote line. All right, sometimes students go like this and say, oh, isn't that a horizontal asymptote line? No, it isn't, right? Because the function has to approach the asymptote line, and we're interested in the end behavior of the function, which this end behavior of this function goes to positive infinity. This just shows, you know, down here I do end up with values that are not part of my range, right? All of these values below y equals -5 are not part of my range, but I do not have a horizontal asymptote line there. Now, if we look at B, okay, so let's go on and look at B. If I were to take that limit as x approaches infinity, okay, and in letter B, I'd also have a vertical asymptote line, right? Because I cannot input 0 for x, right? So I'm going to have a vertical asymptote line at x equals 0, right? I didn't ask you about that in the directions, but I'll point that out anyway. And if I take this limit, x is huge. I have 1 cookie, and I have to divide it up by 1,000,000 people. Right? So this ratio right here goes to 0, right? But then I'm still left with this -3, right? So this goes to 0, and then I have 0 minus 3, which is -3. All right, so I do have a horizontal asymptote line at y equals 3. -3, I'm sorry, y equals -3. Now with radical x, again, if I draw the graph and the way we draw it is very misleading, right? Because this is one of the parent functions you should be familiar with, right? So we draw the graph, it looks like that. And again, so many students come along and say, oh yeah, horizontal asymptote line right there. Okay, that is not the case, because again, if I take this limit as x approaches infinity, I might draw it where it looks like it's leveled off, but really, this is continuing to grow and grow and grow. And it does grow at a slower and slower rate, right, as time goes on. But I do continue to grow. And again, this goes right off my page. It never levels off at a certain value. So this would be no horizontal. So what did I say in the directions? Which functions below do not have horizontal asymptote lines? So I should circle this. I should circle this. Okay. Now, letter C, that's a rational function, the ratio of two polynomials. So that is a candidate for a horizontal asymptote line. All right. And again, if I take the limit as x approaches infinity, there are twice as many cookies as for every 5 people that show up, right? And the degrees are the same. So when I take this limit, this ratio will stay the same, and the number of people and the number of cookies grow at the same rate. So according to the cookie concept, when I take this limit as x approaches infinity, I do get 2/5, right? Because who cares about $3 or $1 when you're rich? This would reduce to 2/5. That's the limit. Therefore, I would have a horizontal asymptote line at y equals 2/5. Okay, so I can't circle that. But in letter D, what I have here, again, a rational function. However, it is top heavy, right? So that means the number of cookies is growing faster than the number of people showing up to eat the cookie. That means I get more cookie, right? So if I take this limit as x approaches infinity, time goes on and on and on, and the number of cookies grows faster than the people showing up to eat the cookies. This limit is infinity. And if I don't get a real number for the limit, then a horizontal asymptote line does not exist. So I would circle this and say this also does not have a horizontal asymptote line. And what we're going to notice with our polynomial functions, all right, and I'm going to be defining that later this week, but our polynomial functions, none of them ever have horizontal asymptote lines, right? So the graph y equals x cubed, that's not a very pretty graph of that. It's hard to draw with my mouse, but it more or less has this shape. There's no horizontal asymptote line. If I let x approach infinity, I would get infinity as an answer. So this also does not have a horizontal asymptote line. And one more word that I want to say about horizontal asymptote lines is we saw them in the bowling example, right? And that had a practical implication. We do see horizontal asymptote lines a lot in life. If you are in biology, which many of you are, and you're looking at population growth of, say, deer, right? The population in an area is going to do this, and it'll get to a certain point where it can't get any higher, right? I can't have any more deer, and that's called the carrying capacity of that region, right? Where the region just could not sustain any more deer, okay? Other places we see horizontal asymptote lines is if you go on a diet, all right, and you cut, say, 500 calories a day, and your weight starts here, and dieters call these the plateaus, right? Well, this is just to be expected. You're not going to lose, diets, they say, oh, you're going to lose a half a pound a week. No, you're not. You're going to lose a lot in the beginning, and then your weight loss is going to level off. You're not going to lose at a steady rate, right? And your weight's going to look like this, even if you follow the same diet plan. Also, if you are in sports, so my daughter is a swimmer, and I remember when she was an 8th grader, she eyed the school record for, what was it, like the 50 free. That was one of her best races as a swimmer. And she said to me, well, Mom, between 8th and 9th grade, I shaved 2 seconds off my time. So if I continue to shave 2 seconds off my time every year of high school, then by my senior year, I'm gonna beat that record. And unfortunately for my daughter, I mean, I didn't want to be a dream crusher and point this out to her, but she was thinking that as time went on, she was going to cut, every year she was going to cut 2 seconds. She was thinking her progress would go like this, right? But unfortunately, her progress went like this, right? And she reached a limit that was not below the school record. Okay, because she might have shaved 2 seconds off from 8th grade to 9th grade, but then maybe the next year she shaved a second off, and by the next year she shaved a half a second off, and she never got to that school record. So there are lots of practical places where we see horizontal asymptote lines. Again, if you're in science and you do certain examples with how your pupil dilates when exposed to light, all right, it's not like your pupil just keeps dilating and dilating and dilating, right? The more light, eventually, the size of your pupil, right, reaches that limit. Okay, so here we are in darkness. You add light, your pupil, if this is the size of your pupil, gets larger and larger until we reach that limit, right? And more light can be added, but we're still at the limit.